Okay, we're going to look at 10.4, but he used 10.1 to go over just a couple of things on the roots and just looking at the assignment here for this. So on 10.1, when I'm looking for the roots of something, and I'm going to start with this number 3 down here. What I've got is um, negative x, the x plus 1, and an x minus 3. So anytime we have just an x, whether it's positive or negative, that's going to be a root of 0. Then for the others, I'm just asking what would make this part of the polynomial equal to 0. So for x plus 1, it'd be a negative 1. And for x minus 3, that'd be a positive 3. So next step, I'm going to place the roots on there at a negative 1, 0, and 3. Then I have 1, 2, 3 x's there. So that's going to be a cube function. And so I know a normal cube function goes up on the right and down on the left. But this one has a negative up front, so it's just going to be flipped around. And we're going to have it going up on the left, down on the right. So that's just telling me what my end behavior is based on the graph. Then, since all of these are just to the first power, they've got one root there, one root there, one root there, then it just goes through it one time, kind of in a straight line, and then back up through that one and down through the other one. And that gives us our polynomial function. Okay, let's look at the number 1 up here. My roots are going to be, I have so x plus 3, that would be a negative 3. And then x minus 5 would give me a positive 5. So those are my 2 roots that I have. But I've got 1, 2, 3, 4 x's there. So that means it's to the 4th power. So any even number, is going to go up on both sides. And if it has a negative in front, it would then go down on both sides, but this one does not. So it's going to go up on both sides. And when I've got a double root here, what that means is instead of going through, it's going to hit it and turn around, kind of like a parabola. So hit there and go back up, hit there and go back up. So when we're looking at, if we zoomed in just on this x plus 3 squared and looked at just that root there, that's going to be, it looks just like a parabolic shape there where it hits, and then that root will be my vertex of the parabola. And of course, it's in a larger function here. And just remember, we don't really know. We're kind of guessing where this curve would be. This curve could be way down here, or it could go way up there like that. Just something we don't know. That's why we're just doing a sketch. Last thing, I've got x plus 2, so that root is at negative 2. And for this one, I've got 3 x's there. So it's going to meet it just like our x to the 3rd power. But just like this one down here, my end behavior is going up to the left, down to the right, because it has a negative in front. So a little bit opposite, but just know it can meet that root in the same way with kind of that curve, and do a great job of drawing that curve, but it gives you the right idea. Okay, so that is an example on that from a couple of it from 10.1. But when we're doing this, What it does is it's giving us a quartic, which means x to the fourth with a double root at 0 and roots at -3 and 5. So to write out the first part, a double root at 0 is just going to be x squared, or x plus 0, x minus 0, however you want to think about it. Then roots at -3. So I'm going to do x plus 3, because the -3 would make that would make this equal to 0, and x minus 5. And so we've also got, it says it contains a point 132. And so what that's doing for us is we have the potential of a number up front here, and we need to figure that out since it gives us a point. So we're going to make that an a value. And what we're looking for is we're going to solve for that a value by putting in this point 132. So that means my y value is 32 equals a times 1 squared. Just putting in my x value of 1 anywhere there's an x. 1 plus 3, 1 minus 5. And what I get is 1 minus 5, that's a -4. 1 squared is 1. And 1 plus 3 is 4. So I have a times 1 times 4 times -4. And that equals 32. So multiplying all this together equals -8a. And to solve for a, I just divide by -8. And when I do that, I end up with an a value of -4. And so that's going to give us our final function is y equals -4 x squared x plus 3 x minus 5. And we're going to use what we know about graphs for that. It says it's a to the fourth. And I also know I've got a double root at 0, 1 root at -3, 1 root at +5. So since there's 1, 2, 3, 4 x's, that means it's either going all up or all down. And for this one, since there's a negative up front, it means it's going down on both sides. And when I look at it, it's going to go, I've got just 1 at -3, so it's going to go through that, a double root at 0, so it's going to hit that like a parabola, and straight down through my +5, and get something that looks similar to that. And look at a couple more, but we're just doing the exact same thing. A double root at -2 means that I have x plus 2. And since it's a double, I'm going to square it. And then we have a root at 1, so x minus 1. Again, there's an a value there that we don't yet know. And so we're going to plug in this point and solve for it. So 6 equals a, which we don't know, -1 plus 2 squared, and then -1 minus 1. So I end up with 2 minus 1 is 1, 1 squared is 1, and then -1 minus 1 is a -2. So you have 6 equals a times 1 times -2, which would just be -2a equaling 6. And again, we'll just divide by -2 to get a equals -3. And to write our final equation there, y equals negative 3 x plus 2 squared x minus 1. And it already gives us our roots. So we have one at negative 2, one at 1. And this is a cubic equation. So that means normally it'd go up to the right, down to the left. But since it's got a negative in front, we're going to go up to the left, down to the right. And negative 2 is a double. So that means it's going to hit that like a parabola and move back up. And then it can go straight down through the other one. And we've got that graph there. Okay, as you go through, we're doing same thing. We will, let's see, cubic equation with roots at negative 3, positive 3, and 1. So we'll look at this one. Remember, we'll have that a value we're looking for. The negative 3 would be x plus 3, and x minus 3, and x minus 1. And I put in an 8 for the y. And all of the x's are going to be negative 1. So that gives me still an 8. A, 3 minus 1 is 2. Negative 4, negative 2. So then I'll multiply negative 4 and negative 2, or 2 and negative 2 gives me negative 4. And negative 4 and negative 4 gives me a positive 16. And when I divide that, 8 divided by 16, a is going to be 1/2. So even when I've got a fraction here, it's a positive fraction, so not going to change the way that we're graphing it. So 1/2, and then x plus 3, x minus 3, x minus 1. And again, it's given us our roots. We have a negative 3, a 1, and a positive 3. And for this one, it's cubic. Got one at each. It's positive up front. So it's going to go up on the right side. Down on the left is our end behavior. And it's just one for each. So we go straight through each time. And we've got the graph of our function. Okay. Also might look down a little bit at the review of logs. Remember, as we're solving this, your easy way of solving it is saying 7 to what power equals 49, which would be 2. Or if we're having trouble with that, remember you always have your calculator option that you can do log of 81 over log of 3. Is your calculator option that you could put in, type just like this. Remember, it's going to give you parentheses. Make sure you close those parentheses. Otherwise, you have the potential of it getting messed up. This one would just be 3. You could type that in and check it just to make sure that you're doing the right thing.